Understanding vector algebra. Here is a test problem for you. It's regarding magnitude and direction. Now, question is, AB is a vector whose tail is at -3, 5 and whose head is at 1, 3. Determine the magnitude and direction of AB. Draw a vector CD which is equal to -2 times AB. So there are two parts to this question. We have already discussed how to find magnitude of a vector. So part A is simple for you. And part B, think about it. And then draw a vector which is twice the magnitude but in opposite direction. So when we write -2, that means minus is opposite direction and times 2 is the magnitude of your vector. So the magnitude should be times 2 and direction should be opposite, right? And then we'll move on to questions relating to scaling vectors. Okay. Now, here is a suggestion. AB is a vector whose tail is at -3, 5. So -3 is here and 5 there. So we have this point as the tail of the vector. And the head is at 1, 3. So 1 and 3. So that is the head of the vector, right? So our vector is AB, which is from this position. So it's going downwards, kind of like this. Do you see that? That's your vector. Now where point A is at -3, 5 and B is at 1 and 3. Now to find magnitude, you can draw a triangle like this. As you see in this triangle, we have a right angle. Now, and AB becomes hypotenuse of a triangle whose one side is 2 units and the other side is 4 units, correct? So that is how you get two sides of a right angle triangle, and to find the magnitude is a square plus b square equals to c square, right? And therefore you can find the magnitude. So you can say magnitude of your vector AB is equal to square root of, so we are basically using Pythagorean theorem or distance formula. Treat those tail and head as 2 points and find the distance between them, right? So the formula is difference in their x values, right? So we go from this to that. So difference in x values is 1 minus -3 whole square plus difference in their y values. That means 3 minus 5 whole square and square root, correct? So you can calculate magnitude from here using this formula, correct? And that's how you do graphically. Now, to draw a vector, that is part B, CD, which is 2 times AB, how should you do it? So what you can do is, you can think like this. This is one vector and then add one more to it. So how did you get this vector? So from here to here, it was going down by 2 units, 1, 2, and then 4 units to right, correct? So let's go 2 units down, 1, 2, and 4 units right. So 1, 2, 3, 4. So we reach to that place. Now, if I continue this vector in the same direction, then it becomes 2 times AB, not -2 times AB. Do you see that? So our vector's direction should also reverse. It should be from here to that place. That's how we can get -2AB from here, right? It is important to note that we necessarily don't have to write or draw the vector in the same position. We can change the position. So let's change the position, right? So let me take both these points. Let's say 3 units down. 1, 2, 3. So that is my final point for the vector CD, and 3 units down. 1, 2, 3. 3 units down. So this becomes my C and that becomes my D, right? Do you see that? Now the direction reverses, right? And this vector CD will also be twice the magnitude of AB. Let's join it over the scale. So that becomes a vector CD, which is twice of the magnitude of vector AP, and it is in opposite direction. So we say scaling of vectors, or multiplying the vector by a scalar quantity. 2 is a number, a scalar, correct? So we are multiplying it by 2, making its magnitude twice, and minus reverses the direction, right? So that arrow pointing from C to D gives reversal of direction, right? So I hope you have learned the concept of how to draw or scale your vectors, right? Or multiply your vectors by a scalar. We'll call it scalar product, correct? So that is kind of introduction to scalar product, right? And we'll slowly move on to more things to be done in vector algebra. Thanks and all the best.